Hello, everybody. All right, so we're going to continue with our discussion of Chapter 4. We're in the Lesson 4.9, Multiply with 9, page 173 of the third grade Go Math textbook. So our essential question is, what strategies can you use to multiply with 9? So let's look at the Unlock the Problem. Olivia's class is studying the solar system. 7 students are making models of the solar system. Each model has 9 spheres, 8 for the planets, and 1 for Pluto, a dwarf planet. How many spheres do the 7 students need for all the models? Well, we know that we have 9 spheres, and we also know that there are 7 students. What are we asked to find? Well, we're asked to find how many spheres do the 7 students need for all models. So how many spheres are needed? Okay, another important piece of information we need is how many students are making models. Well, we know that 7 students are making models. And so if we have 7 students and each model has 9 spheres, we need 7 sets of 9. So one way we can solve 7 times 9, if we're not just going to memorize it, is to use the distributive property. And we can write multiplication and addition for 7 times 9. What we're going to do is break 9 up into 2 smaller factors. So 9 is the same as saying 3 plus 6. So instead of going 7 times 9, I could say 7 times the sum of 3 and 6 is the same thing. Okay, and then it would become 7 times 3 plus 7 times 6. So we've made smaller problems. We've done 7 times 3. We know 7 times 3 is 21. 7 times 6 is 7 more than 7 times 5. 7 times 5 is 35. Plus 7 more is 42. We could also do, if you remember, 7 times 6 is twice 7 times 3. So twice 21 is 42. All right, so 7 times 9 then is 42 plus 21. 7 times 3, 21. 7 times 6, 42. So 7 times 9 is 63. All right, another way we could do that, also still using the distributive property, is to increase the 9 and use subtraction. 7 times 10 is a really easy number to multiply. Okay, so what we're doing here is we're changing 9 to a subtraction problem. 10 take away 1. That's 9, right? All right, so we're still multiplying 7 times 9. We're just using 7 times 10, then take away 7 times 1. All right, so 7 times 10, 70. 7 times 1, 7. So we have to take away 7 from 70. I can't take 7 from nothing, so I'll regroup the 7 tens as 6 tens and 10 ones. 10 take away 7 ones is 3 ones, and 6 take away no tens is 63. So the students need 63 spheres for all the models. Okay? So that's one way to do it. Would it be easier just to memorize 7 times 9 is 63? Sure. Okay. But it is kind of fun to know that I can play with the numbers. I can break them up into different values and still get the same answer. Okay, page 174. Another way, we could use patterns of 9. Nines are very interesting as far as their patterns. So the table shows the 9's facts. What do you notice about the tens digit in the product? Let's look at the product. Okay, here, the product is actually, the 10 is actually 0. Then it goes 1, then 2, then 3, then 4, And then 5. We just figured out 7 times 9 was 63. If we add 9 more to 63, we'd be at 72. And then let's follow this pattern. 1, 2, 3, 4, 5, 6, 7. So the next one has to be an 8. And 9 times 9 is 81. So what do we notice about the tens digit in the product? The tens digit is blank less than the factor that is multiplied by 9. Let's look at that. 9 times 1, the tens digit is 0. 9 times 2, the tens digit is 1. 9 times 3, the tens digit is 2. 9 times 4, the tens digit is 3. So what if I said 9 times 7? The tens digit is 1 less than that, so 63. Okay, so the tens digit is 1 less than the factor that is multiplied by 9. All right, so that's good to know. What do you notice about the sum of the digits in the product? Well, 0 plus 9 is 0. 0 plus 9 is 9. 1 plus 8 is 9. 2 plus 7 is 9. 3 plus 6 is 9. You notice a pattern here? 4 plus 5 is 9. 5 plus 4 is 9. 6 plus 3 is 9. 7 plus 2 is 9. 8 plus 1 is... Oh, so the digits, whenever I multiply by 9, adds up to 9. Some of the digits in the product is always 9. So to multiply 7 times 9, think the tens digit is 6, and the ones digit is 3. So the product is 63. So all we did was say 9 times 7. Okay, so the tens digit has to be 1 less than 7, so 6. The sum of those digits has to be 9, so 6 plus 3. Right, that's kind of interesting. Another pattern that they didn't talk about here, but did you notice what was going on with the ones place? So the tens, we said they're increasing by 1, right? The sum of it equals 9, but the ones digit is always decreasing by 1 from the previous number. Okay. All right. Complete the table above. We did that. Okay. Use the patterns to find 8 times 9 and 9 times 9. Okay, we did that. 8 times 9 is 72. Because 8 times 9, so the tens digit is going to be 1 less than 8, which is 7. It has to add up to 9. The two digits of the product have to add up to 9. So 7 plus what is 9? 2, 72. 9 times 9, the tens is going to be 1 less than 9. So 8, and 8 plus what is 9? 1, 81. Okay, so what is the tens digit in the product 3 times 9? 1 less than what I'm multiplying by, 2. 9 times 8, 1 less than what I'm multiplying by, and it has to add up to 9. 7 plus 2. 2 times 9, I'm multiplying by 2. So the tens is going to be 1 less than what I'm multiplying by, and it has to add up to 9. 18. 6 times 9. Well, the tens digit will be 1 less than what I'm multiplying by, and it adds up to 9. 54. 9 times 1. I'm not going to use any patterns for that. 9 times 1 is 9. All right, number 6. 4 times 9. All right, well, I'm multiplying by 4, so my tens digit is 1 less than the 4, and it has to add up to 9. 3 plus 6 is 9, so 9 times 4 is 36. 9 times 5. 1 less, the tens digit is 1 less than what I'm multiplying by, 40, and it has to add up to 9. 4 plus what is 9? 5. 45. 10 times 9, that's easy, that's 90. 1 times 9, that's easy, that's 9. So you notice the patterns is clearly It's a very easy method to use if you're not just going to memorize them. Okay. 9 times 5, we've already done that. 9 times 3. Could I use a different method? I could. Okay, I could say 9 times 3 equals 6 plus 3 times 3, and then go 6 times 3 plus 3 times 3. 18 plus 9 equals 27. Okay, I could do that. Seems like a lot of work to get 3 times 9, when I could just say, well, I know the tens digit has to be 1 less than what I'm multiplying when I'm multiplying with 9. Okay, 9, 2, and then 2 plus what is 9? 7. 9 times 6. The tens digit will be 1 less than 6. And the sum of the numbers, the digits in the product, has to add up to 9. 5 plus what is 9? 5, 6, 7, 8, 9, 4. 9 times 7. 6 plus 3, 63. 9 times 4. 1 less than the 4. And it has to add up to 9 total. So 36. A beetle has 6 legs. How many legs do 9 beetles have? So that's 6 times 9. 9 beetles, 6 legs. I know my answer has to be 1 less. The tens digit has to be 1 less than what I'm multiplying by. And it has to add up to 9. So 54. All right, 16. Reason quantitatively. Compare with less than, greater than, or equal. 2 times 9 compared to 3 times 6. 2 times 9 is going to be 18. 3 sets of 6, that's the same as 3 times 3 twice. 3 times 3 is 9. 9 plus 9 is 18. Okay, those two are equal. 5 times 9 is 45. 6 times 7. 7 times 3 is 21. Double that. That's 42. So 5 times 9 is greater than 6 times 7. 1 times 9, 9. 3 times 3, 9. Those two are equal. 9 times 4 is 36. 7 times 5 is 35. 9 times 0 is 0. And 2 times 3 is 6. So 9 times 0 is less than 2 times 3. 8 times 5 is 40. And 3 times 9 is 27. So 5 times 8 is greater than 3 times 9. All right, use the table for 22 through 25. All right, so before we look at the problem, let's make sure we understand the table itself. So the table is talking about moons, and we have these planets, and these are the different number of moons for each of the planets. Okay, so that makes sense. Okay, so the number of moons for one of the planets can be found by multiplying 7 times 9. Which planet is it? 7 times 9. Which planet is it? 7 times 9. So I know my product is the tens is going to be 1 less than what I'm multiplying by. So 63. Jupiter. This planet has 9 times the number of moons that Mars and Earth have together. Which planet is it? 9 times Mars and Earth have together. So Mars and Earth 1, Mars 2, add those together, we get 3. So this planet is 9 times as much. So that's 27. So the planet is Uranus, and it's the sum of Earth and Mars moons is 3, and 3 times 9 equals 27. Uranus has 27 moons. Okay, so 24, Uranus has 27 moons. What multiplication fact with 9 can be used to find the number of moons Uranus has? Describe how you can find the fact. Well, that's kind of interesting because we just did that. So we know what has 27 moons. What multiplication problem with the fact 9 can be used to find the number of moons? 9 times 3 equals 27. If I look at the number 27, I know the factor I multiply by 9 has to be 1 greater than the tens in 27. So if I look just at the tens in 27, I know that it has to be 1 more, 3. 9 students made models, number 25. 9 students made models of Mars and its moons. The answer is 18. What's the question? 9 times 2, right? 9 students model Mars and its moons. How many moons were modeled? So that seems like the question, right? If Mars has 2 moons and there's 9 students, 9 times 2 is 18. So basically, the 9 students would be modeling 18 moons. So how many moons were modeled? 176. The library has 97 books about space. John and 3 of his friends each check out 9 books. How many space books are still in the school library? All right, so let's see. There's 97 books total. John and 3 friends check out 9 books each. Each check out. How many books are still in the library? Are still. So that implies I'm going to have to subtract. So what do I need to find? I need to find how many space books are left in the library. Describe one way you can find the answer. Multiply 4 times 9 to get number of books checked out. And then subtract from 97. Okay, so John and 3 friends. So that's 4 people. Okay, that's where we get the 4 from. We then would have to subtract that number of books they all have together from the 97 to find out how many books are still there. Show the steps you use to solve the problem. Okay, so step 1, 4 times 9. If I look at the 4 that I'm multiplying by 9, the tens digit is 1 less, and it has to add up to 9, 36. 36 books checked out. Step 2, 97 books total minus the 36 equals how many books are left in the library. So 97, take away 36. 7 ones, take away 6 ones, leaves 1 1. 9 tens, take away 3 tens is 6 tens. So there are 61 books left. 61 books still in the library. All right, so complete the sentences. The library has 97 space books. So this part here is basically explaining what we did up to this point. Okay, so multiply blank and blank to find how many books John and his 3 friends check out in all. What did we multiply by? We multiplied by 4. 4 times 9. There were 4 people. They each checked out 9 books. After you found the number of books they check out, we subtracted to find the number of books still in the library. So subtract to find the number of books still in the library. And so there are 61 space books still in the library. And 27. Circle the symbol that makes the multiplication sentence true. 9 times 7, blank 3 times 3 times 7. Okay, so 9 times 7 we know is going to be 63. 3 times 3 times 7. 3 times 7 is 21. Okay. Well, we can also rewrite this problem. Okay, I actually want to rewrite this problem using the associative property. Associative property, remember, tells me that it doesn't matter which way I group my factors, I'll get the same product. So I could say 3 times 3 times 7. Did I change the numbers? No. Did I change the operations? No. So all I did was group the 3 with the 3 instead of 3 times 7. 3 times 3 is 9. 9 times 7. They match, right? So these two problems are equal. What if you did keep it that way? Well, it would have been 3 times 21. And so that would have been 3 sets of 21. 3 sets of 21. So I could just add those. 2, 4, 6. Okay. Regardless, it's still the same answer. They are equal to each other. Okay. Using associative property, though, makes it more obvious that they're equal. Okay, because I can wind up with the same multiplication problem. Okay, so that's it for lesson 4.9. In our next lesson, we're going to be talking about problem solving using the multiplication skills we've learned so far. So until then, may the numbers always be in your favor.